So, thank you so much, all of you, for joining us today. Let's start by talking about the AI landscape in general and how that is impacting the Indian economy. Now, we know that AI has a transformational role and a pivotal role to play for India's economy because it has applications across all the important economic sectors which really impact India, like agriculture, healthcare, defense, and even finance and economics. In fact, there are market reports out there which suggest that in the next 20 years, AI is going to touch parts of the economy which are going to total almost about $1 trillion. The Indian government, has also been very supportive in helping AI scale, either in terms of supporting startups or in terms of supporting the industry. There have been programs like the AI Bharat Mission or the National Program on AI, which are encouraging the industry, the academia, and also the startup space. Now, in the light of all of this, one question that really stands out is that India, given its demographics, is very different from the Western world. So, are the models which are developed in the West, or are the AI technologies which are developed in the West, which are primarily focused on English language per se, or takes into account the way the Western society is set up, will those models, or are those models relevant for India, or does India need to develop its own fundamental model? So maybe we can start with Priyank.
Yeah, I mean, that's a very basic question. That's a fundamental question you're asking about AI, right? AI has come in and it is like electricity about 100 years ago. It's going to change everything in the economy. It's going to be everywhere. But AI hasn't just arrived. It has been taking a leap and bound and become into the public consciousness just recently. I mean, if you look at my first exposure to AI itself was at Search when I was leading the product management for Yahoo Search Pack Technologies, and we were doing machine learning. So the analogy that I have come to understand is there is an element of understanding of the data that requires a whole picture view. That time it was understanding of the web content, all the HTML and other content of the web. Today it's about all the data that's available, trillions of tokens. But that understanding is done at a holistic picture. And on top of that, uses are derived. That was an example of search. Here it's queries, analysis, etc. The amount of data that needs to be analyzed to create a compendium of human understanding from all the content we have created, that is very large. And while India is not the first in getting this fundamental knowledge built, India is unique in the sense that a lot of the context that we have in India, of our lives, of our social lives, of our economic lives, as well as our political systems or our languages, is not there in that data. So we do have we are benefiting from that technology development, from that concept development, but we do have an ability to do something that is on top, which is unique to us and very contextual to us. In my view, if you look at all of these underlying technologies, when the technology comes, it always creates a lot of excitement around it, whether it was electricity or otherwise. The actual value is actually delivered when the uses of those technologies translates into customer applications. I feel, and this is something that I think about a lot as a venture capitalist investing in the AI space, the fundamental technologies has to be understood. I'm not saying that India should not endeavor to make headway there, but there is an opportunity to apply the technologies, whether it be for LLM, large-scale LLM models or doing fundamental LLMs, to Indian applications and create value there, which will be unique, to India, may also benefit to other South, global South, while at the same time, those application development will create a need for further going down the value chain or going up the value chain depending on complexity, how you define it. It's like assembling phones. You might think assembling phones is the lowest cost effort, but that creates the demand to create the fillback industries, whether you have the component suppliers, and then behind the component suppliers, the research. So we need to do this part to create the knowledge, awareness, and applications, and that will create the justification for next advance, where we will have a sense of what the value creation mechanism is, and then potentially drive new fundamental advances in AI. You mentioned about English being one of the places. I mean, if you think about it, a company like Microsoft is spending $80 billion to build data centers today. It's not going to be possible for India to compete with that. But what can we do is, if we take it to our context, if we take it to our SLMs, if we take it to potentially new fundamental research on top of it, which, I mean, people are talking about AI having hit kind of a potential data plateau, maybe architectural plateau with transformers have brought us here, but maybe what next? So we need to build the fundamental understanding, but we don't need to despair the fact that we were not the ones to bring it and we are not necessarily keeping up with the US or China. We need to understand our strengths and align our efforts with making the best of it.
Absolutely. I think that's a very valid point, that we don't have to feel left out and go necessarily after fundamental research, but also think about what applications we can build in the Indian context and see how we can scale from there.
I mean, I will just say we have to go after fundamental research. We just have to don't despair that we missed this out and we'll not be able to compete. We just have to go to the next step. This ship has sailed, as many will say, but there's a lot has to be done, right?
Absolutely. And while doing all of this, talent, sir, becomes a very important aspect, because unless you have people who are driven, unless you have people who understand technology, and unless you have people who are groomed up in a way that they can, understand the intricacies of technology and how they can be applied in a regional context, I think we are going nowhere, because India is a people, it's a place with a very large population, and a lot of that population is young population. So it's very important for us to groom talent. So do you have any insights on what the Indian academic groups can do to nurture talent so that we can, meet this end goal?
Yeah, there is indeed a lot of things we need to do in academia to prepare ourselves for the AI, that's coming at such a breakneck kind of a speed. But if you look at Indian academia, most of this research is still concentrated in the computer science departments, and computer science departments in good institutions are, it's very difficult to find good faculty, and you are always competing with Googles and Microsofts. When it comes to hiring a top researcher, why would somebody come and join an academic institute rather than go to Google and Microsoft, get maybe 5 times more salary and still do research, right? So that is becoming a big bottleneck for all academic institutions when it comes to hiring. And another major challenge I see in India is our siloed way of doing research. The computer science departments, because there are a few people and everybody wants to collaborate with them, and but computer scientists are also very difficult to work with. I have seen enough computer department both in Bombay and IIT Bombay and IIT Delhi. They are all very intense kind of people working on their own problems, and suddenly a biology researcher goes to them, I want to work with you in sharing some of these. It doesn't come naturally for them to spend time on that, understand their problems, apply that. I think it becomes a big challenge right now. In our existing institutional framework, with everything is departments and that siloed kind of a thing, we will never be able to make a mark. I mean, whatever we do might lead to some good quality publications and all of that, but we will never develop the kind of models that we need in the country, taking into account our linguistic diversity, or any demographic diversity. I don't think we will be able to develop models, in this kind of an approach, because it requires a very highly multidisciplinary kind of a thing. I think that's where institutions need to invent. At IIT Delhi, for example, when I was there, we started a school of AI, and we said there was of course resistance to starting the school of AI, and much of that resistance came from computer science department. They said, they will start competing with us and all of that. We said that's not the reason why we need school of AI. The school of AI will focus on applications. It will only hire faculty who will work on application domain. It will have the great biologists, it will have climate scientists, it will have let's say people working in industry 4.0. It will have people who work in different application domains, but who have a knowledge of AI, who have who want to apply AI into these domains, and it will only have those application people while the core development can still happen in the computer science department, but these are the people who will connect with the rest of the institute and rest of the disciplines, and they bring that application focus, right. That's how we started School of AI. It was funded by an alumnus with a $10 million kind of a contribution, and so all that worked very well. That is the approach that we need to take. In BITS Pilani, where I am now, we are actually starting a new campus. The new campus, which is going to be in one of the states, is going to focus entirely on CSC curriculum, right. But then every student there in the entire campus will work on CSC related topics, but and with AI as a major focus, but they will also do at least 2 minor degrees. The 2 minors, one could be, the minor options could be agriculture, security, right, environment, and climate science, or all of these kind of domains, agriculture. So all of these domains they will do minors. So they learn the core AI principles and tend to apply them in one or two of these domains. So they know the agriculture problems. They will also know where AI can be applied. So that's a kind of a curriculum we are building there. And because AI at the undergraduate level will be too focused. The undergraduate curriculum can be a little bit broad based, and where they learn all the AI techniques and tools and all of that, but then they will, by doing these minors in application domains, healthcare for example is one big area, right. By studying healthcare kind of subjects and by knowing AI, because you are a computer science student, can you apply and develop applications out of that. So more experiential kind of learning, working in real world problems with the core AI that you learn. So the entire campus is going to be focused on some major themes in AI, computer science kind of areas, and minor degree programs in application domains. I think we need more such experiments in India. Otherwise this very siloed way of doing it is not going to take us anywhere. Another major issue is number of scientists per million population. India currently has less than 300 scientists per million population, whereas developed countries like Germany, US will have anywhere from 4,500 scientists per million population. So unless we scale up the scientist space, unless our institutions start recruiting more and more people, go out of the Indian origin, India kind of faculty thing, we need to open up our academic institutions, and we need to look for talent from all over the world. And unless we do all of that, with a few people working in these areas, we will never be able to make a mark. And I think on one hand there are resource constraints, on the other hand you have so few people working in these domains. I think we will always be big consumers of these technologies, but developing anything on our own will require a completely different approach to how we train people, how we do higher education today.
Excellent point, sir. I think we need to definitely rethink the way education system works in India and take a less siloed approach. But there's an interesting aspect that you just brought about, and that is the end application area for a technology. And I would really want, Sanjay to please pitch in here. You've been in the industry in the semiconductor space for decades now, and I'm sure you've seen applications of AI, LLMs, and across different industries. So, do you want to paint a picture of which industries and which application areas excite you the most?
Sure. So first of all, very relevant point by my two fellow colleagues here. What Professor said, how we make it happen through the real life multidisciplinary kind of approach. I think we from industry are trying to do something in that direction, and I will try to explain it. Like when we build an AI product, eventually in a some way we are trying to compete with the biggest creation that God has done, that is human brain. And the way to think about that is a human has eyes, ears, and maybe something called intuition that we have not been able to decode. These are the equivalent sensors that semiconductor technology is trying to build up. If you take a reference of a drone or a car as an example, they have now embedded radars, embedded lidars, ultrasonic sensors, and many new innovations, camera sensors. They are trying to replace that aspect of God creation, right? That is driven out of semiconductors. Once you sense something while driving a car, human process that information, tries to decode that information, what it is all about. Is it a cow on a road, or is it a human being, or is it a traffic signal? Same way, to decode that information, we are trying to do something called intelligent compute. Right? And that intelligent compute is trying to take input from sensors and putting these very complex GPUs and central processing units, the video processing units, and trying to make some sense out of this huge data that is driven out of semiconductors. Now, once you do that intelligent processing, you put some kind of algorithms and then put a controller to make some actions out of that. Right? In other way, you put the control logic to take some decisions which excite our hand for a steering wheel or a foot for a brake. Same way, there are the microcontrollers which take the action after these compute units have done their job, and eventually there are actuators. Right? So these are the four verticals of semiconductors, that the sensing part, the thinking part, and the acting part. Right? And eventually humans are connected with the outside world using, again, the eyes and the gestures. Right? And that is the equivalent of a connectivity technologies that we have. Whether they are within automotive, you have the Bluetooth technologies or ultra wideband, and then you have a long range connectivity technologies like Wi-Fi and many more. So if you look into that landscape, everything semiconductors is one word, but within semiconductors there are hundreds of sub departments, and each one is trying to convert that natural phenomena through semiconductors technologies, and the end product has millions of application. It could be, if it is automotive, this become automotive industry. Right? And by the way, today automotive is one of the fastest driver for electronics penetration, semiconductors penetration. Today you enter into any car, you want to have a feeling of your living room. Right? The fancy looking 12-inch TFT touch enabled dashboard with the GPS and audio video connectivity and all that. All that is powered by semiconductors, and that is driving the future growth in automotives. Today, India's demographic profile, you go with your kid to buy a car, right? You will end up buying a car that is looking more fancier from inside with all these tech gadgets that they know better than us. So very, very important area in terms of end application, which is driving the industry. Within automotive, if I talk more, we are trying to build a future that will be driven through autonomous cars, right? As you say, a cell phone on wheels. And we are trying to work with some of the key customers, both Indian and European customers, where each car will be loaded by high double-digit cameras, high double-digit radars, LiDARs, all together. And the data fusion is something that is a technology you call, so that if my car wants to take a autonomous decision, it is better vetted by two other technologies. Otherwise, it could be a threat to human life. Right? So all these technologies create multi-gigabytes of data transforming into a car and within a car architecture per second. The capability of handling this huge data, imagine if you have 1 million WhatsApp messages coming to your phone, what will happen, right? So that kind of intensity, today's modern car, or you can put any mobile device, it could be a drone for that matter, which has a very important defense application, which we are seeing right now around the world. Right? All these technologies are loading huge data generation mechanism, data processing mechanism, data transmission mechanism, and data storage mechanism. Right? And all that is obviously a big challenge. How you devise your technologies which can handle this data without dissipating too much of power. Otherwise, all good things have a side effect, and power consumption and dissipation could be a big challenge that will make this unviable. Right? You talked about defense. This is a major technology driver right now around the world. You talked about agriculture. Sir talked about agriculture. How we compete with the rest of the world in agricultural basis, so that automatically you can figure out which areas to water, which areas not to water, and the humidity control automatically, where drones are taking care of that. Right? All this is amazing application areas that are swamping us. So I would say it is that technology and engineering is actually lagging behind the demand. The demand is already there. It is for up to industry to work with big institutes, both across India, within states as well as outside India, and scale it as fast as we can. And with the right funding coming, I'm sure a lot of startups are going to make a big name for themselves and for the country.
Absolutely, sir. I think I am very excited personally about the autonomous vehicle space because it takes me about an hour to get to office every morning. So I wouldn't mind cars
I
becoming
would
more.
just skip autonomous and someone solve for teleportation. Let's
Oh,
start.
yes,
That's the best
absolutely.
way.
Yes, exactly. All right. So, Priyank, I have a rapid fire question for you before I move on to my main question. And that is, do you think AGI, artificial general intelligence, is going to be a reality anytime soon? Yes or a no answer?
Yes. If you force a rapid fire, yes. But there's so many caveats into that whole conversation that it will take another 15 minutes to just talk about that.
I know. That's why it was a rapid fire question.
Yeah,
But
yeah,
no,
yeah.
excellent. Because Sanjay talked about the closest thing to God creation is AI, and I think the next frontier for us is artificial general intelligence. As you look at startups, especially AI focused startups, what are the things that you look for when you find look for your next funding
See, it's
opportunity?
a very interesting situation. What's happening is AI technologies are moving so fast and their applications in the digital domains where data is being manipulated is transforming so quickly that while we see a lot happening, sometimes as an investor, we are not even sure that this what is being done by this company will survive too long. And still, there are good companies there which we look at and we are investing in. We did recently announce an investment in a company which does brain data analysis to understand the connectivity, which is what's called the brain connectome. So it's all soft data, and what they are doing is understanding how your brain different parts function and what are the areas that are connected, where you do sight, where you do listening, where you do control your motor functions, executive function, and so that neurosurgeons and epileptic surgeons, dementia, all of that can be diagnosed. But what is also parallelly to be understood is we are still using the same glass bottles that were first invented like 100 years ago, motors that were designed 100 years ago. We are using carpentry techniques and technologies that were from those times. We are using electrical transmission mechanisms, dishwashers and appliances. They're getting digitized. What I mean to say is there's a lot that is not changing in the physical world as quickly as it's changing on the digital world. And so, what I've come to now think about, having looked at a lot of startups, there is applications of AI to transform our ability to understand and manipulate complex areas where there's a huge amount of data and variability. You look at biology, whether it be applied to health and medicine, whether it be applied to agriculture. You look at materials, subatomic scale interactions, how are materials going to be developed? And all of these things, you look at natural systems like climate, weather systems. You look at these things being applied, whether it be applied to circularity of materials, whether it being applied to supply chain management. So my tendency today is to think about if the application of AI is bringing transformation in a physical world, that is often a bigger impact as well as potentially more defensible. Now, I'm thinking like an investor, right? I need to find companies where, for the people who have trusted us, our fund with their money, and I've been investing for myself for 17 years, but now investing other people's money as a VC. I want to make sure that I give them good returns. I can do whatever I want with my money, it's all my fault. But with other people's money, I have a fiduciary responsibility. So I am looking for companies that have a moat that will make an impact. So we are seeing AI, as I gave the example of brain, we are seeing AI being applied to, smart grids. We are seeing AI being applied to motor designs, solutions for energy efficient, rare earth free motors, etc. So this is the kind of application of AI applied and enabled only with the help of semiconductors, because some of these designs that we are talking about were conceptualized, I don't know, 1880s is one particular example I know. And it is only possible now because of semiconductor based response time, which is powered with AI algorithms. So AI is changing our digital interface, our experience on the phone, and all our smart devices very, very rapidly. How we handle data, how we manage our organizational data, how we handle information within our day-to-day working. But it is also going to accelerate change in the physical world in ways that people are just dreaming of. We talk a lot about humanoid robots, and they are going to make an impact. I'm not questioning that. But people can't, in the public imagination, think about all the different things that we sometimes come across that they're being applied to. And the ones that succeed there are going to make such a big change. I mean, technology that you don't see and it becomes part of you is actually the real transformational technology, right? Uh, who thinks about electricity except when it goes away? And you can't do anything today without electricity. So that's the kind of applications of AI that will really change our lives. And that will happen when they are applied to real world problems rather than esoteric edge case applications only, which is what is sometimes cool for public consciousness because it dazzles you, and many of them will come, but not all of them. The ones that are going to come are going to be the subtle ones that are going to change our lives much more dramatically. So that is something that I think about when we're looking at startups, how much of a moat they are, and they often find it, as Professor Rao hinted at, in these interdisciplinary areas. If you look at the most successful universities in India, in the US, they have all, when we did our engineering, it was all about what department you were in. All of their new structures are multidisciplinary structures. They are no longer creating Department of Engineering, like computer science or Department of Electrical. They are creating bioinformatics or intersection of multiple disciplines, because that is where the transformational changes are happening. When computer science is applied for all of these examples that he alluded to, I hinted at, that is where the new knowledge is being created. That's where new opportunities are, and that's where the startups are also, and that's where the industry is going to also make go.
Professor Rao, would love to get your views on the democratization of education, which are making access to education easier and cheaper, and anywhere in India, any place, somebody can learn the latest and the greatest technologies. What are your views on that, and how do you think that is disrupting the education sector?
Yeah, I think India needs all such platforms because if you look at our higher educational institutions, our gross enrollment ratio is about 27-28%, meaning only 1 in 4 students coming out of schools can find a place in a university today. We don't have enough places. All our good institutions, the tier 1 institutions, are also pretty tiny, right? 1%, 2% is all what they can admit in a year, and that's not going to help us much as a country. So that's where all these online kind of platforms will be very useful, and we need to promote them. All good institutions also need to get into these platforms. In fact, I'm happy that some IITs and even BITS Pilani is launching a major initiative are into the online space, so you can reach out to more children. And I think the regulations also sometimes come in the way today. There are a lot of restrictions from the regulators on what you can offer online, and I think these institutions also need to learn how to enable such processes. I think there are a lot of regulatory challenges, but despite that, today I can take a course from anywhere and get a certificate. Getting a degree and all that, you still need to go to a recognized institution and do all of that. So that part is definitely happening. But one thing which is also missing is that experiential learning aspect, right? While I can go sit in front of a computer and learn something, but if I have to apply it somewhere, right, I need to be, having that immersive, that immersion kind of a program associated with just the learning part of it online. I think that is the kind of a model that we are trying to develop now in some of our institutions, where you learn things online, you listen to a lecture online. Otherwise, who says that 8 to 9 I should do chemistry, 9 to 10 I should do maths, 10 to 11, I think those things are gone. It's all anywhere, anytime, on demand kind of an education. But so that part can be easily ported to an online platform, but the experiential learning part will still require you to go to a laboratory, build an application, demonstrate it to people, make it work in the real world scenario. So that is where we need to focus on. I think the India's higher education sector still is too much theory, right? Less of practicals and less of hands-on kind of a thing. That is one thing that distinguishes Indian education system with, let's say, the US education system. At BITS Pilani, for example, we offer a lot of joint degree programs And in that we need to map the courses, because we both are giving degrees. The student take courses here, students take courses there. Invariably we find that our curriculum is at least 25% more in terms of theory than what a typical American school would do. Meaning 1 in 4 courses, is additional in the Indian kind of an education system. Too much of classroom teaching, less of experiential and the laboratory training part of it. That needs to change. While all these online platforms will be able to replace a classroom teaching, you can even ask questions. There are synchronized kind of learning processes now, and the teacher is available, you can discuss and all of that. But online program needs to integrate with the experiential learning part, that immersion part, that we are not doing very effectively. And that is where the brick and mortar kind of institutions will become a necessity, right? And that's where you need to go to a center and do some projects under some supervised kind of a way, demonstrate something unique. And I think that currently is not happening as much as we want it to. And that is one change that you will see, coming out of some of our institutions now.
So we just have to extract the best out of online and offline and
Hybrid approach.
hybrid
That's
approach.
the best.
And just as I close this section, a rapid fire question for the both of you. How do you keep yourself updated about the latest and the greatest technologies? Maybe Sanjay, if you want.
Mine is these days YouTube. I
Excellent.
see in the travel time, this is the best way, especially if you are flying, you have 3 hours, you can have a lot of knowledge from these YouTube videos.
Right, excellent. And Priyank?
I'm a podcast guy.
Excellent.
Podcast on the road, podcast on travel, podcast on the flight.
Okay, awesome. All right, so now we'll shift gears and we talk about what are the challenges that we face while we try to scale AI, and Siddharth is going to take that section.
So by now we have established the fact that AI is important and it will drive the next revolution for India and the world. So the next pertinent question and the aspect that we would like to touch base is challenges faced by the organization to scale AI. And few of the challenges that we have heard in forums are lack of training data, lack of talent, lack of right tools and infrastructure, right? Governance and ethics is a problem, and sustainability at large. So climate change is a problem, and there is a lot of emissions that is there when you compute for AI, right? So I would like to have maybe Priyank, you can start with.
Okay, I mean, there are two aspects to this question. One is at an organizational level, and one is as a industry level. I mean, I'm an undergrad in computer science, master's in computer science, so excuse me if I have hubris that I understand this, but let me give you my perspective. There's limits to how much public scale data is available for training AI. That is starting to be talked about by everybody in the valley, including the people who are working on the models. I think the newest model of ChatGPT that they're working on, they found that 20% of the training through, they had most of the learning, and beyond that, it started to plateau out. That was quite earlier than they expected because they already reached such a high level. On the other side, the compute element is, of course, becoming a constraint as well, the data centers that they're building and all that. So there needs to be some fundamental research to take it to the next level. But one thing to understand is, if you look at the other examples in the world that are of technologies applied at this scale, and I take the example of search again. When we used to build search engine, there used to be the backend element that used to take a heavy compute, and it used to be a large part of the data center utilization from a Yahoo search or Google search. But when searches grew the way they grew, the actual sub-second response to generate for each query, with the number of queries, million queries per second, with the inference element, not the training element, the inference stage became the larger compute. Not because there was more data being handled, but because there were so many people applying it for so many use cases or so many touch points that became the big constraint, and that had to be optimized for. I feel the same is needed for AI. We have been building these models, the technology is now become available, but what's going to be required is going to be technological advancements or algorithmic advancements that make the inference part much cheaper. I already read some papers where it goes like factor of 58 down or something by some small loss of fidelity. Also, what this will go into is, and the industry level, people like Sanjay's company will come up with designs of chips which are going to allow AI at the edge. So your base model training at the center, combined with local context, maybe some local model layers, and then local inference. The GPUs that are being used today were designed for graphics processing. Graphics processing is you get a video stream and you present it. You need to do a lot of rendering. So it's a one-way flow design. AI adopted GPUs because a neural network design is composed of a lot of separately operating nodes with millions of nodes, and with a lot of separate processors, you could do compute parallelly. But the data flow in AI is very different from a GPU. And so there needs to be new architectures that have come up in semiconductors which are designed for AI. I am sure he is working on that. Many companies are trying to solve that problem. Even companies in India, we say, claiming to do that. I'm not the expert enough to know who's solved the problem. So those kind of technological enhancements to take this technology to the daily life will come from the industry. They will require semiconductor designs, they will require deployment at scale, and they will enable local inference, local context. If you go to an organization itself, which is how does a particular organization apply AI, there it's a entirely different problem. There it's, I think, more of a skill and culture problem. First is who has the skill to bring it inside the organization. Many organizations within the country are still not doing cloud for their email. They are still trying to run SMTP servers because the IT departments don't know how to change things. People don't have the skill. We are talking like God knows how many generations ahead of compute. That doesn't mean organizations will not do it, but there is large number of touch points on organizations, that need to develop and bring in the skills to bring AI to the everyday organization. The ones who will try first will work the hardest. While the industry comes to make the applications easy to deploy, people didn't deploy email until you had simple package software SMTP server, right? That didn't. Once the internet was working within university, that didn't result in companies changing. So that skill has to percolate. It has to become simpler. It has to become more packaged, well understood. Then the skill can go out. But the other element is the cultural element of getting an intuition of what AI can do and what AI cannot do. A lot of AI projects today are not succeeding because people are still trying to figure out, there is a fancy demo, how does it translate into a real life situation? My manufacturing facilities outputs depend on it. How much can I rely? How do I bridge this gap? There's a lot of distance between these two gaps. So there is work that needs to happen, not just at the organization level, at the industry level, to package these solutions. And then on the industry level, there needs to be an effort to create skill, some frontier skill, but a lot more cultural skill and readiness to adapt to these new ways of thinking. You're gone from a well-defined deterministic model of interaction with computers. You press this button, this is going to happen. Unless the power goes away, this is exactly what's going to happen. Every time you do that, that's the same thing's going to happen. Now everything is probabilistic. So it's going from like a Newtonian mechanics to quantum mechanics, right? Things are not so obvious. So that kind of a cultural mindset, what is it that you can rely on and what is it that you need to cross-check? People who are going to apply AI will need to build a sense that I can use it for doing this, but this is the points where I need to make sure that I bring in the ethics, I bring in the safety, I bring in the brand, whatever element I want, and that will take some time. So that is the aspect which is going to take a lot more effort, and I won't blame the organizations that are trying for failing. They are the ones who are solving the problem for the others in the world who are going to come in the future, but it's not easy. Even the people who are making the technologies are not yet clear how to do it.
I would really like to hear from Sanjay sir. Is edge the next big thing, as he said?
Yeah, so as Priyank explained, one of the data I was reading, to do an average chat GPT computation at the central, it dissipates heat for which you need an equivalent of multiple Olympic sized swimming pool water, right? Just to put it in context. And if millions of people are putting those queries and trying to use AI, at some point the current architecture is going to choke. It is non-sustainable and also impractical. So where semiconductor is going to, I think, take a shift from this continued momentum is having AI capabilities on the edge. And for a common man, edge could be anything that is the last node that is talking to human. For example, a smartwatch could be my edge device, right? So if it has to measure, say, my health parameters or how many calories I'm burning, and based on that need to give me some pre-indication. It should do some of the edge level calculations, computations, without transmitting every bit of data into the cloud and then take it back. Because if everybody start doing it, it will completely blast, right? Edge computation, edge AI is the biggest thing in semiconductors right now, and every company, because when you say edge device, it could be automotive, car could be considered as edge device, smart watch could be considered as edge device, many gadgets including our refrigerator or washing machine could be considered as edge device in industrial, right? So every one of these devices will be loaded with small tiny chips which have intelligence. In the FIFA World Cup, we had soccer, football had a very tiny little chip which was intelligent. As Masa Sen, the founder of SoftBank says, in days to come, human shoes will have more intelligence than our whole first PC, because it will have the intelligence that how a particular person is moving and walking and what could be the medical related challenges the person is facing, right?
I mean, just to add, I was just thinking while he was talking about edge devices, right? Look at me. I have a smartwatch, I have a smart ring, I have an AirPod, I have a phone, and then the speaker, like five edge devices
Yes.
on one person right here.
Absolutely. And that gets me thinking. We were at a conference a few days back, and somebody said that LLMs are not the next big things. It is SLMs, which is the next big thing, because they can be more easily deployed on edge devices. Do you have thoughts on that, because you come from a computing background?
Yeah, I mean, SLMs are obviously a way to reduce the footprint and apply it to context, and then make it more, you know, movable to an edge device like this. How they pan out, how effective they are, the technologists who are building it know better than me. The other thing I think is that what you are calling the large action models, LAMs, LAMs or SLAMs, those are going to become more important to affect our lives. As he said, you need to actuate or do something. Those are the ones that are going to make the robotic devices work. So SLMs, SLAMs, or maybe, I don't know, whatever comes next will be what will be good. I mean, Transformers brought us this. Who knows what else is out there?
Exactly. And there's one question on talent which just came to my mind, which I would really want to ask Professor Rao about. So, as we scale AI and the demand for AI talent increases and the AI technology matures, what is also happening is the traditional Indian developer is sort of getting redundant, because a lot of the basic coding can actually be done by, say, programs like ChatGPT. Do you think the job market is going to shrink and there'll be less job opportunities but more specialized job opportunities? Or do you think AI is just going to open up more avenues and so the job market is going to expand?
That's a very interesting question. But before I go to that, this scalability, I also have at least a point to add there. I come from nanoelectronics area. The Moore's law was what was the driving force, behind all the advances you saw, mobile phones becoming so powerful and all of that. The very important aspect of Moore's law was it doubled the speed, right? But it also reduced the power consumption by half. With every increased generation, when the Moore's law, traditionally has increased the performance, reduced the energy per operation. That is how you were able to pack so many things in a mobile phone and all of that. But when it comes to the AI and all of this revolution, it's a brute force scaling, right? Now you are scaling at 500x, 1000x. There is no Moore's law at work now. The only way you can do is keep on adding more GPUs, and all of them will keep on consuming so much power. I think that is the biggest challenge right now. So at some point, energy is going to be a very, the sustainability is going to be a very important aspect for all the scaling that you are seeing, because the Moore's law not being present anymore, I think now this whole brute force approach of keep on adding more GPUs is going to limit eventually everything, and I think that is one issue. And when it comes to the scaling of the talent pool and all of that, we are already seeing the impact of that. In fact, last year, right, there were the jobs were reduced by at least 1/3, right? The job market, the placements and all of that, every institution struggled to place their students, and the reduction was almost like 1/3. And this year, I just saw a news report from a major US software company saying they are not going to hire any more coders anywhere anymore, because with the existing people, with the improvement in their efficiency, they are already able to get a lot of work done. So therefore, they don't need to recruit more coders kind of a thing. I think this is the times now in the future, this is going to be a trend. The simple coding kind of a job, will be like the data, what was that, the call center jobs, right? Call centers, every building used to have call centers, and so many call centers in many cities, all of them have vanished now, right? The same thing is going to happen with the coding jobs too, and so most of it will be taken away by these LLMs kind of tools, and the role of an engineer is to, you generate a code using these tools, and then you do the debugging and do a little bit of polishing, finishing, and that it gets to work. So that efficiency will go up, therefore you don't have to add so many people. The only way, institutions can still find jobs is to upgrade the skills of these students, and at the end of the day, that innovation is what matters, right? You need to be able to apply and realize something that will still be in the human domain. The computer and all these tools will tell me what to do, but they will not go to the field and actually install, some of these things and do the things. So I think more practical skills, right, will be what are required. And on the other end, if you are doing theory, then it has to be much higher levels of theory. I think the middle level will all be gone, while the lower end, you still need plumbers, you still need carpenters, you still need all of them to install things. But at the higher level, people who can design, code, develop these models and train these models, all of that will also be required. The middle routine kind of jobs will all be gone. So I think our institutions, either you need large number of skill development institutions, right, or you need institutions would produce higher levels of skill, who can actually build LLMs and who can train these models and all of that. So the middle level at some point, will have a problem.
So I just want to add to that is, our family business is manufacturing, and we have always been starving for talent in manufacturing. My hope is that the lure of IT jobs, as it goes down because of the erosion of the demand, will have talent move to your mechanical or your your civil or the other industries. As you said, physical goods. We are all talking about the interfaces to our physical interface. And that will encourage talent to come there. I know of industries in India which are dying for talent, which are not on the technology side. The manufacturing industries, many industries, the air conditioning industries where we sell to, everybody is talking, I don't have good people, I don't have good people, how do I find? Now, you might say they don't know how to train people, they're not willing to pay, but ultimately the economic forces may create a diversion of the applications of talent. All of this, to be able to do a semiconductor plant that a company like Mr. Sanjay's will, send designs to, they will need people to handle that physical stuff, right? We will need people to apply medicine. So I hope the economic forces will divert talent to these places which are going to be more economically lucrative. I mean, in our institute, I am an IIT Delhi graduate. Even the textile engineer or the mechanical engineer, everybody went to technology or went to finance. Nobody did their core engineering but if they did, that could be, and the economy had the demand for that, then that's the next wave of possible change.
Just to add to his point, this year data, the real data, because I get to follow the placements and all that are happening. This year, the median salaries, right, have gone up by at least 15%.
Okay.
In our campuses. We are talking of a tier 1 institute, 3,500 graduates and all of that. Why has it happened? It has happened because of semiconductor jobs becoming available now. A lot of recruitments are happening in the semiconductor sector, but these are not the coder kind of people. These are all people who can do VLSI design, go to a lab, build a device, and that kind of skills. So those jobs in India are now becoming available thanks to the India Semiconductor Mission. Suddenly this year, because semiconductor industries tend to be, much better employees. When I don't want to equate it to becoming better employees, they pay more, right? So the average salaries a semiconductor industry would pay is much higher compared to what a software IT kind of a job is, and therefore the average salaries have gone up, and students are happy. But that is the skill that you require now. So for other institutions which are entirely surviving on coding kind of jobs, they will struggle. But the tier 1 institutions which can produce students who can do VLSI design, who can do manufacturing kind of a thing, who know the semiconductor kind of basics and all of that, they will be much better off. So I think that upgradation of the skill is what is important in all of that, from the jobs and from placements and from all of that point of view.
Sanjay sir, do you have
Yeah, exactly. To
views?
add to this point, see, we in semiconductor industry are also facing the same talent challenge. Right? There is so much to do, but talent is just not there. As a matter of fact, one of the research says the overall 40% of the world's talent, although is in India, but still India has less than a lakh semiconductor professionals. So out of a population of 1.4 billion, right, it is a handful of people actually, if you see that way. So talent development is as much as our challenge, as much as universities challenge, and as much as
VC's challenge, yes.
VC's challenge. And what we are trying to do is how we engage with universities at a very, very early stages, have some kind of a shared purpose and a shared goal, because we cannot survive. It's it's not either or, it has to be together. So what kind of internship programs that we can do for a year-long duration, where hands-on, multidisciplinary kind of exposure, as Professor was saying, could be done jointly, where they get the cutting-edge research from the university background, and they get what is the leading-edge requirement in the industry, and they can possibly do a fusion of the two. And they can actually show the way to some of the seasoned professionals who have not seen the latest part of the research, and how new technology can actually do wonders in the productivity. And I think that is a challenge for probably every industry who is employing semiconductor professionals in India. And then retention becomes the next goal, because if you have so much of demand supply challenge, then you train them and they leave, right? So that is another issue. So how you create enough long-term growth of potential, jointly do the partnered masters and future career build-up programs with universities, so that you keep on engaging with them for a long term. That is another important area, because I do feel that one of the drawbacks of this huge explosion in economy is our youngsters are getting very short focused, and they jumped into software and IT, and maybe if they jump into semiconductors, the real value in semiconductors cannot be realized at least 3 years down the line, because the whole development cycle, unlike software coding, which you can do possibly in less than 6 months, here it is like a minimum complexity, average complexity, you need 18 months. And then after 18 months, you have another cycle of product validation. If it is a life-threatening kind of a application, a healthcare application, pacemaker inside a heart and all, it need much longer cycle. Right? So you need to have the sustenance for long term. Then we can definitely take India also onto the global platform with the proven products coming out of India.
I would like to just add one point to that. I think the core jobs, right, will come back with a vengeance. That will happen at some point in time. Today, for example, you could take a civil engineer and train that person to become an IT professional, right? Teach some coding, the guy is fine, right? Or the person is fine. But those jobs will go to all these AI tools, right? That won't be available. And when I say core jobs, the way the core skills are provided today, they will not be able to make a big impact in the sector. When I say civil engineering, right? Civil engineering now needs to encompass environmental engineering. Civil engineering need to look at building 3D buildings, right? There are lots of things that are happening in civil engineering which are very futuristic. New materials. Can we find replacements for cement, which is such a environmentally disaster kind of a material? So can we, and that will require new skills in terms of materials. Now if I have to build a building using 3D kind of printing, you need to impart different kind of skills to the students. The core sectors need to be completely revived with these new technologies. Civil has to encompass all of that. A mechanical engineer now needs to look at mechatronics. A mechanical engineer needs to use smart, the industry 5.0, industry 4.0 kind of technologies. I think unless these core departments upgrade their curriculum, I think get into some of these newer age the new age kind of technologies, they will not really serve any purpose. So I think while the core sectors will come back to prominence, but they will also come back with a completely modified kind of a curriculum. So therefore, adjusting the curriculum to keep pace with what is happening in the society is becoming very important. Our institutions need to completely reform themselves when it comes to some of these areas.
Excellent. Awesome. Thank you so much, Professor Rao, Sanjay, and Priyank, for being a part of the show today. And I'm sure our audience will get to learn a lot of things. And I certainly, for one, had fun. So thank you so much for your time, and hope to get together again sometime soon in the future. Thank you so much.
Yeah, thank you. Thank you, everyone. Thank you.
Thank you.